Today we are going to discuss a problem from uh, laws of motion. This is 2009 JEE mains. This question is from 2009 JEE mains. Okay, so let me go through the question. A piece of wire is bent in the shape of a parabola. Okay, a piece of wire is bent in the shape of a parabola y equal to kx square with a bead of mass m on it. The bead can slide on the wire without friction. Okay, nice. It stays at the lowest point of the parabola when the wire is at rest. Okay, fine. Let's first understand. Let's first put it into a picture uh, till this. Okay, so what we have a piece of wire. Okay, we have a piece of wire. Let this be the wire. Okay, and this wire is bent in the form of a parabola. Okay, so let me draw the coordinates x and y. Okay, this is x-axis, this is y-axis. Okay, and this purple color wire is bent in the form of a parabola y equal to kx square, right? Y equal to kx square is a vertical parabola. If you want to confirm, you can just put some values for x and y, and you can plot a rough graph, say 1 1 2 4. If you take k as 1, it will be something like this. So from this you can understand that the curve, it is already stated in the graph, it is already stated in the question that it is vertical parabola, but even if it is not stated, you can from y equal to kx square you can understand that it's a vertical parabola. My parabola doesn't look that great, but let me redraw it. Okay, it's a parabola, so let me curve it out. Okay, okay, this is comparatively better. Yeah, so this is a parabola, and in that wire, so right now this wire, thin wire, is bent in the form of a parabola, and there is a bead in the wire. Okay, there is a bead which is passing through this wire. So right now when we put it into this vertical parabola, of course because of gravity, the same bead will be at this center. Okay, the bead came to the center. Center means at the bottom, at the bottommost point, right? And it has a mass of m, so there must be a weight mg acting downward. This is its present condition. Okay, now what is being given? Yeah, it stays at the lowest point of parabola when the wire is at rest. Natural, quite understandable. Because of mass, it comes to the bottommost point. Okay, because of the gravity, the wire is now accelerated parallel to the x-axis with a constant acceleration a. Okay, great. That means the entire the wire, somebody is holding both the ends of the wire. Okay, and it is being moved horizontally. It is being moved horizontally with some speed, with some acceleration a. Okay, with some acceleration a, it is being moved to the right. It is not stated whether to the right or left. It is just moved parallel to the axis. You can put a towards the left or right. Okay, I'm taking it as towards right. It is being accelerated towards right, like this. Okay, so naturally what happens, the bead must have moved to some other location. Okay, let's see what the question says. The wire is now accelerated to the x-axis with a constant acceleration a. The distance of the new equilibrium position from the y-axis of the bead. where the bead can stay at rest with respect to the wire. Okay, the question is this. Right now, when you move it with a good acceleration towards right like this bead must have moved to some location here. Okay, it no longer, this was its initial position. Okay, and now it is here. Okay, because it got accelerated, the entire system got accelerated, so it found a new equilibrium position. Initially the point 1 was the equilibrium position. Now point 2, that point 2 we don't know where it is. Okay, that point 2 is the equilibrium position. Okay, we are asked to determine the distance of the new equilibrium position from y-axis of the bead. Okay, from y distance of the new equilibrium position of the bead from the y-axis, where the bead can stay rest. Okay, fine. So let's take, this is the point where now the bead is at equilibrium, bead is at rest. Okay, but the entire system is moving. The entire system is moving towards the right with an acceleration a. Now, the bead, with respect to the wire, the bead has come to a point where it is at rest. Okay, we are asked to determine that distance from the y-axis. That means we are asked to determine this distance. This is the distance at which it has come to a new equilibrium from the y-axis. Okay, it could be, they could have asked from x-axis also. Okay, what could be this distance? That could have also been asked, but right now they asked only for this distance. Okay, so let's see how to solve this. So let me draw the system once again. This is the x-axis, this is the y-axis, and this is the parabola. Okay, and let me put a point mark here denoting the center. Okay, denoting the bead center. Okay, so this was the initial position, this is the final, this one is the initial equilibrium. Okay, point 1 is, sorry, point 1 is initial equilibrium, point 2 is the final equilibrium or current equilibrium. Okay, now the question is to determine this distance. Okay, fine. For that, let me put the point 2 as, the coordinates of point 2 as x comma y. Okay, the coordinates of point 2 is x comma y, where what is x? X must be this distance, right? And y must be this distance. Okay, this height. Okay, so this is a coordinate of point 2. Basically what we want to find out is the x, this distance at which the bead is now resting. Okay, so let's try to see what are the forces acting on the bead right now. Okay, let's go one by one. Definitely there has to be a vertically downward force which was already there here. Okay, mg acting vertically downward. Okay, that is one force, you cannot avoid that. And you know, your whole system is moving with an acceleration a. Okay, right, the whole system is moving with an acceleration a. So this bead must also experience a force in this direction. The mass of the bead is m, so it should experience a force of ma. Okay, it should experience, so these two forces should be there, mg because of the weight, ma because of the acceleration of the system. Okay, then what else could be there? Yeah, of course, the bead is lying on the wire, right? So the wire must be there must be a normal reaction force from the wire. Okay, because the wire is holding it. Wire is holding the bead, so there must be a normal force. A force, normal force is it's a reaction force. Okay, so at point two, let's say let's say this is the tangent at point 2. Okay, then there must be a force normal to the tangent. That must be the reaction force. Okay, so these are the forces acting on, these must be the forces acting on the system right now. So on the bead, there could be three forces. One is mg acting vertically downward, another one is ma, another one is n. N is nothing but normal reaction. Okay, normal reaction. Okay, suppose this happens at an angle theta. Okay, this happens at an angle theta. Then uh, let me write down the system 2 at point 2. The system is at equilibrium. Okay, it has reached equilibrium, that's why it is staying at point 2. If it is at equilibrium, I can say the net force must be 0, right? So let me balance the net force. First, let me take the vertical force Fy. Net force on vertical direction must be 0. That means, what are the vertical forces? There is one mg acting downward. So this mg must be equal to n sine theta, because we have n here. Okay, this is n. It is acting at an angle of theta. Then it could have two components, n cos theta and what, n sine theta, right? So here mg is being balanced by the vertical component of n, that is nothing but n sine theta, right? This is one equation. This is obtained from balancing the vertical forces. Now we know, since it is in equilibrium, the net force in horizontal direction must be also 0. That means the force ma must be equal to minus n cos theta, right? Both ma, say ma is this, must be equal to n cos theta magnitude wise. Okay, direction of n might be different. Direction of n could be different. N might have been acting like this, I don't know. But I'm taking this, I'm just putting this direction. But you can see the n cos theta and ma must balance. Then only it can be in equilibrium, right? So I would say, or maybe you can consider the n must be acting in this direction. Then only this ma can be balanced. Okay, so these things as you solve the problem, things can be altered. Okay, things can change. So right now I'm putting n is like this. Why? Because I know the ma must be cancelled out, so n has to be in this direction. Okay, so again, let's come back to the force ma equal to n cos theta. So this is equation number 2, right? So we have mg equal to n sine theta, ma equal to n cos theta. Let me divide equation 1 by equation 2. Then I will get mg by ma is equal to n sine theta by in cos theta, right? That means here n and n gets cancelled. Tan theta is equal to g by a. Okay, tan theta is equal to g by a. This is one thing which we got. Tan theta, we just got that this angle is equal to g by a. Now let's again come back to the geometry. Okay, suppose this is the parabola, this is the horizontal line, x-axis, this is the vertical y-axis, this is the point 2. Okay, the point 2, this is point 2, right? And there is a tangent. From geometry you can see this is a tangent passing through point 2. What is the slope of this tangent? And we know our normal will be perpendicular to this, right? This is a normal, this is a tangent. The dotted line is the tangent, the solid line is the normal, right? And at this point we just got that tan theta. We know this is tan theta, right? So sorry, that we know that is theta. Okay, let me mark that. This angle is, we have taken as theta. Okay, so if this is theta, okay, if that is theta, the tangent, what must be this angle? The angle of the tangent, this is theta, right? So if we extend this, this will also be theta, right? This is 90 degree, so this angle must be 90 minus theta. Okay, so this angle is 90 minus theta, this one, right? So what is the slope of this tangent right now? Slope of this tangent is tan 90 minus theta, right? Let me draw once again for your easiness. Say this is our parabola. Okay, this is the horizontal axis, this is the vertical axis, y-axis. Okay, this is the point 2. The point 2 has a tangent. Okay, this angle came out to be how much? 90 minus theta. Okay, what is this angle? Which pass angle when considering this point? It is a slope of the point 2, right? If this is point 2, this angle is slope of point 2. That means slope of 2 is dy by dx. In an xy graph, the slope of a point, say suppose you have a graph here, something like this. At any point, say this is x, this is y. At any point, the slope is given by dy by dx, right? So slope of point 2 is dy by dx, and which must be equal to what? Tan 90 minus theta, right? So dy by dx must be equal to tan 90 minus theta. Okay, that is cot theta. That is 1 by tan theta. That is what? We already have tan theta. We already obtained tan theta as g by a. So cot theta must be a by g, right? A by g. Okay, that means dy by dx is equal to dy by dx at point 2. Okay, at point 2 must be equal to a by g. Okay, but what is the equation for this curve? This curve is, we know this curve is y equal to kx square, right? Y equal to kx square. So what must be dy by dx? Say, we know y equal to kx square. So dy by dx is equal to d by dx of kx square. That means 2kx, right? So dy by dx is equal to 2kx. dy by dx is equal to 2kx, which is equal to a by g. So x must be equal to a by 2k into g. Okay, x must be equal to a by 2k into g. That means the distance of that point, that means this is our wire, this is the y-axis, this is the x-axis. Okay, this is point 2, which has got x comma y as the coordinates. This distance, okay, this distance is x, and it is obtained as how much? X equal to a by, look here, a by 2 kg, a by 2 kg. Okay, so let's go back to the question and see whether there is an option. Yeah, you can see the option B, a by 2 kg. So that must be the answer. Hope you understood. This is, as I said, it is 2009 JEE mains. You can just understand the question and try to solve it by yourself. Okay, thank you.